Okay, so in this question we have y equals, and it's 3x squared plus 6x to the 1/3, and we're going to split up this part. So that's plus 2x cubed over, and we'll also write the root as a x to the half. So that's 3x to the half. Then we have minus 7 over 3x to the half. And then the next step will be to simplify these two terms here. So we get 3x squared plus 6x to the 1/3 plus, this is a 2/3, so that's 2/3 x. And here we must subtract the indices, so 3 minus a half, that's 5 over 2. Then minus, that's a 7/3 x. And the x to the half at the bottom becomes an x to the minus half on top. And now we're ready to differentiate. So we get dy dx equals 6x plus a third times 6 is a 2, x to the minus 2/3. And here, if you multiply 5 over 2 with 2/3, we get 5/3. X to the 3 over 2, and here minus a half times minus 7/3 is positive 7 over 6, x to the minus 3 over 2. Okay, so in this question we're given a function y equals x cubed plus 4x plus 1, and we need to first differentiate it. So we get dy dx equals 3x squared plus 4, and now we need to sub in x is 3 equals 3, we can plug in 3 plus 4, that's 27 plus 4 equals 31. Okay, so part A, we'll begin by writing y equals, and we'll just write it as a double bracket first. So 1 minus 2x, 1 minus 2x. And then we'll expand this, so that equals 1 minus 4x plus 4x squared. And now we're ready to differentiate. So therefore dy dx equals, so the 1 disappears, and we get a minus 4 and plus 8x. So that's part A. For part B, we'll begin by writing y equals x to the 5 plus 6, and we're going to rewrite the root x as an x to the half, and that's all over 2x squared. And now we're going to split up the fraction, so that gives us x to the 5 over 2x squared plus 6x to the half over 2x squared. And next step, we're just going to simplify each term. So here we get a x cubed, and the over 2 we're going to just write it as a half, so that's half x cubed plus, so 6 divided 2 is a 3, and we have x, and here we have to do a half minus a 2, so that's minus 3 over 2. So now that we've split up the fraction, we can now differentiate it. So here we get dy dx equals 3 over 2x squared, and then it's minus 9 over 2 x to the minus 5 over 2. Okay, so in this question we need to differentiate this function and work out the derivative when x equals 8. So we'll first begin by writing it in index notation. So we have y equals x to the half plus 4 over x to the half plus 4. And then we're going to bring the x's onto the top. So we have x to the half plus 4x to the minus half plus 4. And now we can differentiate it. So dy dx equals half x to the minus half, then minus 2x to the minus 3 over 2, and the 4 disappears. Okay, so now that we've differentiated it, we're now ready to sub in x equals 8. But just before we do that, it's preferable to rewrite the indice notation back into surd notation. Whenever we're trying to solve equations or sub numbers in, it's easier if it's in surd notation. So let's just rewrite this. So this becomes 1 over 2 root x. So we have the half is the 1 over 2, and x to the minus half is over root x, and then minus 2 over, and this becomes x cubed all rooted. And now we can substitute 8 in. So when x is 8, therefore we get 1 over 2 root 8 minus 2. I'm just going to switch the order. I'm going to do the root 8 first and then cube it. And here we can just use the calculator and it should give us the answer. And we get root 2 over 16. And we better just write it how they want it. They want it as a root 2. So this will be 1/16 root 2. Therefore a equals 1 over 16. Okay, so in this question we're given a function y equals 4x cubed minus 1 plus 2x to the half, and we need to differentiate it. So we get dy dx equals, so we have 3 times 4 is 12 x squared, the minus 1 disappears, and then we have plus 2 times a half is a 1, and then we have x to the, and we minus 1 is a minus half. And that's the answer. Okay, so for part A, we're given an expression 2 root x plus 3 all over x. And we need to write it in this form here, 2x to the p plus 3x to the q. So we'll begin first by splitting up the fraction and also writing the surd as a indice. So that's 2x to the half over x plus 3 over x. And now we'll simplify each term. So we get 2x, and there's a little 1 here, so that will be half minus a 1, so that's minus a half plus 3x to the minus 1. So that's part A done. And part B, we're given that y equals 5x minus 7 plus the same thing that we had in part A, and we need to differentiate it. So let's write out y first. So that's 5x minus 7 plus, and we're just going to replace this with this over here. So that's plus 2x to the minus half plus 3x to the minus 1. And now we can differentiate it. So we get dy dx equals, so 5x becomes a 5, a minus 7 disappears, and we have 2 times the minus a half, that's minus 1, that's minus 1, and then we have x to the minus 3 over 2, And then here we have 3 times the minus 1, so that's minus 3x to the minus 2. And we do need to simplify each term, so we have to simplify this a little bit. We can't have a 1 there. So the final answer will be equaling 5 minus x to the minus 3 over 2 minus 3x to the minus 2. Okay, so in this question, we're given a function y equals x to the 4 plus x to the 1/3 plus 3, and we need to differentiate it. So we get dy dx equals 4x cubed plus 1/3 x to the minus 2/3, and the plus 3 disappears. Okay, so in this question we're given a function y equals 2x squared minus 12x plus 16, and we need to find the gradient of the curve at the point 5, 6. So we're going to have to differentiate this first. So we get dy dx equals 4x to the 1, and then minus 12, and the 16 disappears. And now that we've differentiated, we can now plug in x equals 5. So this is our x coordinate, and this is the y coordinate. We're not going to use the 6 in this question, only the 5. So x equals 5. Therefore, we get dy dx equals 4, 5 minus 12. So that's 20 minus 12 equals 8. And that's the gradient. So the gradient is the same as the derivative. Okay, so for part A, we'll begin by writing y equals x to the 4 plus 6 root x. And the first step will be to prepare this for differentiation. So we want to get rid of the surds and write its index notation. So we have that as equals x to the 4 plus 6x to the half. And now this is ready for differentiation. So dy dx equals 4x cubed plus 6 times a half x to the minus half, and then we'll just simplify that. Gives us 4x cubed plus 3x to the minus half. Okay, part B, again we'll begin by writing y equals x plus 4 all squared over x, and we need to expand and simplify this first of all. So that's a double bracket, x plus 4 all over x. We'll expand the numerator. That's x squared plus 8x plus 16 all over x. And now we need to split this up and simplify. So we'll first do the splitting. So you have x squared over x plus 8x over x plus 16 over x. And now we'll simplify this. That gives us x plus 8 plus 16x to the minus 1. And now we're ready for differentiation. So dy dx equals 1, and it's plus, the minus 1 comes down and multiplies to 16x, and we minus 1 of the power, and we can simplify this is 1 minus 16x to the minus 2. Okay, so in this question we're given f of x equals 3x plus x cubed. And part A, we need to differentiate. So this is already ready for differentiation, so we can just do that straight away. So f dash of x is 3 plus 3x squared. And part B, we're told that f dash of x equals 15. And we need to work out what x is. So we're going to replace f dash of x with what it is. So we have 3 plus 3x squared equals 15, and we can solve this for x. So therefore 3x squared equals 12, then x squared equals 4, and so x equals plus and minus root 4, which is plus minus 2. And if we look over here, we're told that x is bigger than 0. So therefore, final answer, x is 2. Okay, so in this question, we're given a function f of x, and we need to express it in this form here. So it looks like they've expanded the brackets and simplified each term. So part A, we have f of x, and we're first going to write it as a double bracket, and also, instead of a surd, put indices. So here we have 3 minus 4x to the half, and another 3 minus 4x to the half, and that's all over x to the half. And the next step is that we're going to expand the brackets. So we get 9 minus, so we have 3 times 4 is 12, and another 3 times 4 is 12. So that's minus 24x to the half. And then this is a positive 16. And x to the half times x to the half is just an x. And that's all over x to the half. And the next step is that we're going to split up the fraction. So we have 9 over x to the half minus 24x to the half over x to the half plus 16x over x to the half. And now we'll just simplify each term. So the first one becomes 9x to the minus half, then minus, the x to the halves cancel here, there you go, and we're left with a minus 24, then plus 16, and here we have an x to the 1, so 1 minus half is a half, so this is x to the half. So that's part A. And part B, we need to differentiate. So we have f dash of x equals, and we can differentiate each term. So here we have 9 times minus half is minus 9 over 2x to the minus 3. The minus 24 disappears, and then we have plus, and 16 times a half is an 8x to the minus half. So part C, we need to work out f dash of 9. So we need to plug 9 into here. So we can do part C, f dash of 9 equals, so minus 9 over 2, 9 to the minus 3 over 2, plus 8, 9 to the minus half. We can use calculator here, and if we use calculator we get 5 over 2. Okay, so in this question we'll begin by first writing the surd in index notation, splitting up the fraction. So we have y equals 8x cubed minus 4x to the half plus, and here we'll split up the fraction, so 3x squared over x plus 2 over x, and we will now simplify this. So we have 8x cubed minus 4x to the half. Here we get a 3x, and here we can bring the x up to get a 2x to the minus 1. And now we're ready for differentiation. So we get dy dx equals 24x squared minus 2x to the minus half plus 3 minus 2x to the minus 2. Okay, so in this question we're given a function y equals 5x cubed minus 6x to the 4/3 plus 2x minus 3. And part A, we need to differentiate and we need to simplify each term as well. So we get dy dx equals, so the first term becomes 15x squared. The next one becomes minus 6 times 4/3, which is minus 24 over 3 x, and then you minus 1 off the power is a third. The 2x becomes a 2, and the minus 3 becomes a 0. And then we just have to simplify this. That fraction simplifies, so we get equals 15x squared, and this becomes a minus 8 x to the 1/3 and plus 2. And part B, we need to do the second derivative. So we have d2y by dx squared equals, and we can differentiate this, gives us 30x. And here the third comes down, gives us minus 8 over 3 x, and if you minus 1 off a third you get minus 2/3, and the plus 2 disappears. So that's the final answer. Okay, so for part A, we're given an expression 2x squared minus x to the 3 over 2 all over root x. And we need to write it in this form here, 2x to the p minus x to the power of q. So we'll first begin by splitting up the fraction and writing the surd as an indice. So we have 2x squared over x to the half minus x to the 3 over 2 over x to the half. And now we can simplify each term. So we have 2x, and we have to do 2 minus a half, which is 3 over 2. Then minus x, and here we do 3 over 2 minus a half. So that's 1.5 minus a half, that's 1. So that's just 1. We don't bother writing that, or we can because they want it there. And we have to write down the value of p and q. So p equals 3 over 2 and q equals 1. Okay, part B, we're given that y equals 5x to the 4 minus 3 plus this term here, which is part A. So we're just going to copy that as 5x to the 4 minus 3, but we're going to replace this with this over here. So plus 2x to the 3 over 2 minus x, and we need to differentiate it. So we get dy dx equals 20 x to the 3, and the minus 3 disappears. That's plus, so 2 times 3 over 2, that's 3, x to the 1/2 minus, and then x becomes a 1.